I will be discussing the problem remove nth node from end of list. The problem statement says, given the head of a linked list, remove the nth node from the end of the list and return its head. So there are two approaches for this problem. One is iterative approach and second is recursive approach. Linked list is made up of nodes where each node has exactly two pieces of information. We have our current value and the pointer to the next node. We will use two pointers. Let the distance between the two pointers be n. They will be incremented at that same time, and once the first pointer hits the end, the second pointer is going to be n from the end. Iterative approach. The solution code removes the nth node from the end using a two-pointer technique with a dummy node to safely handle edge cases like removing the head. First, a dummy node is created and linked to head. Pointer P1 starts at the head and moves through the list while a counter tracks how many nodes have been seen. Pointer P2 starts at the dummy and only starts moving once P1 is more than n nodes ahead. That means by the time P1 reaches the end, P2 is sitting exactly one node before the node that needs to be removed. Then we simply skip the node by setting P2.next is equal to P2.next.next, effectively deleting it from the list, and finally returning the dummy.next as the possibly new head. The recursive approach says that this approach removes the nth node from the end by counting backward as the recursion unwinds. The helper function remove node travels to the end of the list, and as it returns back up the call stack, it computes the position of each node from the end. One for last node, two for second last, and so on. When that backward index become n plus 1, it means the current node is exactly one node before the one that must be deleted, so it keeps it by updating node. Next, by updating node.next is equal to node.next. After recursion finishes, the function returns the function checks if the removed node was the original head, which happens when the total length equals n, and if so, it moves the head forward by 1. Finally, it returns the updated head of the list. The time complexity of this solution is big of n, and the space complexity is big of n as well. Okay, the patterns which are observed while solving this case are: one is two-pointer technique, fast, slow / gap method. Create the distance between pointers so one pointer lands at the right node when the other finishes. Single pass optimization, learning to solve problems in big of n without extra traversals. Next is dummy sentinel node usage, where powerful trick to simplify edge cases, especially when modifying the head. Pointer manipulation and relinking, carefully changing next references without breaking the list. Next is edge case thinking, where deleting head node, deleting last node list of size 1 to thinking ahead instead of reacting. Recursive backtracking on linked list, where we are using recursion to count from the tail backward. Next is index from end versus index from start. Mindset shift, many linked list questions think backward from the tail. In place modification, constant space solutions by using structure itself instead of extra memory. Structural traversal mindset, we don't index in the linked list, we just travel via pointers. Next is clean and safe updates, where we always update links only once we are sure, avoid losing reference to nodes.